Hello everyone, my name is Avkash and let me save you significant amount of your time daily if you are a pandas library user. Most of the data scientists use pandas library almost daily or maybe hourly basis. So if you are one of them, with today's tutorial, I'm going to save your significant amount of day, almost daily basis if you are not using the library called Modin. On your screen, we have Modin project website, which is hosted on GitHub. And this is not something really very new project, it's few years old project. And if you look into their tagline is very clear. Speed up your pandas workflows by changing a single line of code. It means all of your existing code where you have used pandas is not going to be changed at all. You are just going to replace where you are loading your pandas or you are importing your pandas, and that's all. Everything is going to be as it is. So what is Modin, how it works, I will be explaining you later through my example. So let's first start with an example, see the value and the power and the performance of Modin. Then after we will talk about what is Modin and how it works and how it's going to help you significantly. So I already have a Jupyter notebook pre-created for you guys. So I will be running it, and because it's going to take significant amount of time when we are trying to process a very large data set, so I will expedite that area. I will fast forward and I will show you the result. So that's what you are going to see in this tutorial. And by the way, before I start my presentation, if you like my content, please do subscribe it and share it, and I will definitely appreciate it. So let's get started. So you must have Modin installed on your machine. I will start here. I'm using pandas 3.9. As you could see here, I do have pandas 1.4.1 as well as I have Modin 0.14.0 installed. And for the data set, what I have done is that I have already collected massive amount of data on my machine related with US or global wildfire data. I will be showing you in my next Jupyter notebook how you can have almost billions of rows worth of data downloaded from the NASA website, but that's second. I am importing the pandas and the modin pandas as it is. So the difference is really very simple. Whether you are using pandas or you are using modin pandas, you can import this way. For the difference in our example, the pandas I will call PDO, means pandas original, and modin.pandas I will just call it PD. So it's really very simple. So wherever I will access PD, think it's a modin panda, and where I'm accessing PDO, it means it's the pandas original. With Modin, you have to config. So Modin comes with few engines within itself, and if you do not define any engine, then by default it automatically sets up the Dask engine inside, and I will be explaining that later. So we have config the engine, and currently I'm using the Dask engine, but you could use Dask or Ray. They pretty much have almost identical performance. There are a few things here and there, but for the starters, just use the default. Once you have engine ready, you have to config the distributed client, because underneath Modin, the Modin is taking the power of every CPU core available in your machine. Pandas just use a one single CPU core. So with the Modin, if you have 16 core, if you have 8 core in your machine, you are going to get the speed because of your workloads are distributed across multiple CPUs, and that's the secret behind Modin. So Modin is configured, the client is ready. Now I will be showing you the data set here. So I have a mixfire CSV here, which is 3 gig CSV file, and I do have the compressed version of that file also, and that is 664 meg. So in this example, we are going to read the zipped CSV as well as the regular CSV. So first I will be using the regular CSV, and I'm using the pandas datetime library to just get the difference between these modin.pandas and the pandas call in seconds. First, I'm reading PDO, means original panda, and we will see how much time it takes to read the mixfire CSV, which is about 3.0 gig. And as you could see here, it took 75 seconds for us to read about 37 million records. And the file size was not the zipped one, so it was a 3 gig file. On a regular pandas took 75 seconds for 37 million. Now we are using the modin pandas. Code is almost identical, there is no change, and there you go. For the same amount of records, it took 41 seconds. So it's about just little half of time is taken to read the exact same amount of rows. So definitely you have saved a significant amount of time. Now we are going to read the zipped version of that. So even when you are working with pandas or you are working with your data set, you are going to read most of the time data once, but you are going to process that data again and again and again. So the performance will definitely going to improve and the time will be reduced every time you are going to use the pandas library. Here I am using the zipped version of CSV. So let's start very first with the original panda, and then we are going to immediately start with modin pandas. And one thing I just wanted to let you know that when you are reading the zipped file, there is still overhead to process the zip file and get the CSV out of it. So you may not be going to see the significant performance update because of the type of data is there. So that's, I just wanted to point it out earlier. And as you could see here, it took 104 seconds. Initially it was 75 seconds. So the difference in time is because of we were reading the zip file. So the overhead was already been added into the pandas original library read time. Now let's use the modin pandas. And we are still using our zipped file. And here you could see that the time to take this almost 3 gig file with 37 million record while you were reading the zip file, it's about 98 seconds. I have done this test multiple times, and with original panda it was between 100 and 112 seconds, and with modin pandas it was between 71 all the way to 100. So the difference was not too much, and there were two big reasons. One, that it's a zip file, so overhead is almost similar to read the zip file and process it, because that time the pandas is not active when we are just reading the zip file. It means the data frame related part is not active, because first we need to unzip this zip so we could read the data set and then convert it to a pandas data frame. So this warning sometimes you might see and sometimes you might not see, but that is all related with the runtime environment underneath. So there is no significant saving, that's not a problem. Now we will validate that both of our data frames read by pandas and the read by modin pandas, they both are identical. Now I have one example. Here what I will be doing is that I will be taking the data frame. I will just use one of this. So this data frame is actually a collection of United States and global wildfire data. And in this data set, I have about 5 or 6 countries data. And these countries are, I would just give you United States, Australia, Greenland, Papua New Guinea, Mexico, and China. So 6 countries worth of wildfire data in last 21 years. So this data set has a longitude, latitude, and it also has the fire confidence because the data is collected through satellite. So external algorithms used after the snapshot was taken through satellite instrument, the infrared instrument, and guess whether this is the wildfire or not. So this confidence value is between 0 to 100. So that's the confidence value we are using in our next step, and what we are trying to do is that we are trying to process this data in a way so that we can calculate how many times at a particular longitude and latitude that wildfire happened. So in last 21 years, we are looking into a particular location in the size of 10 square kilometer. So first what we do, we are taking this data set and setting up the longitude and latitude precision to one single decimal digit, which gives us about 10 square kilometer area. And then we are doing the group by operation, so we could calculate that at a particular longitude and latitude, yearly basis and monthly basis, how many times fire happened. So fire count is being incremented, and then at the very last, we take all that data and we try to create a plotly hex map, and using that hex map and the heat map, we try to understand that which area at these given 6 countries are the wildfire hotspots. So that's visualization all inside this about 12 line of code. So I will be showing you the processing using the pandas as well as using the modin.pandas, and you will see that how much time we are really trying to save in this process. If you are interested in this code, I do have a whole video available, and that available at my YouTube channel. So please go to my YouTube channel and search for United States and the global wildfire data visualization, and I have various hands-on lab and tutorials available on how you could generate this data and detailed explanation about how everything has been done. So please go ahead and you can look into it if that's what interests you. Now I will start this operation with pandas, and as you see here, our pandas data frame is PD and the modin data frame is dfpd and dfmod.mo. So I will be using here. So you see that there is a dfpd, and wherever it's really used, everywhere we are using dfpd, and for the modin I will be using dfmod. So I will be starting this code, and the objective of this code is to group by, run bunch of pandas processing. Oh, sorry, precision is not defined. Precision. Let's run again. So our job is done. So it took pandas about 16 seconds to process these 37 million records. Do the first set up the precision, then convert date time properly, set 2 new columns, ran the 3 group by operations. We have ran for total fires on 4 columns. Then we ran the yearly fires on longitude, latitude, and yearly, and finally the global fires on 2 columns. So we had 3 group by operation, bunch of column specific operation for 37 million records, and for pandas it took about 16 seconds. Now we have about 1.7 million aggregated records for longitude, latitude on yearly, monthly basis, that number of fire on that 10 square kilometer longitude and latitude based geo area. And this is our data set look like. So these are the yearly fires and that are the global fires. So global fires are about 202,000 records. Now using the plotly and the map box, so in order to see this visualization, you will have to have your mapbox token. Is free. Just go to visit mapbox.com, sign up, and you are going to get the token, and you can use your own token. If this token works, that's okay, because I have taken somebody else's token from h2o.ai tutorial. So if this token doesn't work, you can use your own. So I will be loading the plotly and setting up the mapbox token to use with plotly library. Now we are going to create the visualization here, and it took about 3 seconds to set up this visualization. And as you could see here, that among these countries, here are the hotspots related with fire. So you could see here that Australia has the really high end wildfire, some of these southern part of United States has the wildfire. You can also see the Hawaii also has some of the wildfire. China is also, there are some of the hot spots. So these are the hot spots we have figured it out for these 6 countries which we decided in our data set. So this is just for you to try with whatever data set you would want. I just wanted to show you that how we are doing with pandas versus modin. I wish I could have more records. So right now we have only 202,000. I wish if I had about maybe 5 million aggregated records, and that's going to take too much time, and that's the reason I didn't put that whole global wildfire data. That would have been a great exercise if somebody would want to use it. So rather than using these 6 countries, you can spend some time and you can combine everything to one single data set. Now we are going to use the modin.pandas. So we are using this dfmo, and let's get started. And remember, when we perform this processing for this regular pandas, it took about 16 seconds. So let's see how much time it takes with modin.pandas. And it took about 19 seconds. And if I will go ahead and I will run it again, so you will get various sample size and 15 seconds. If I will run one more time, and reason this is because number of CPU core available when this code is running. Because I have a machine where underneath background so many processings must be running, my camera is running, recording is going on. So it is very much possible that sometimes not all CPU cores are available. But and one more thing is that when we are doing these group by operations, sometimes you may not be able to get that performance. It's depend on what you are doing and what is the workload available on the given machine. You are going to see the performance with modin.pandas. So here we didn't really save significant performance. I ran this code several times and I was seeing about maybe 2 to 3 second improvement, not much there. Okay, now it's the same data set. So we are going to see the map with this global fire, and it took about 3 seconds. So there is no significant improvement because at this time when we are building this graph, we already have our data frame ready. So that is all done through the plotly library now. And now if you would want to create another map, I just have a free gift for you. So if you are new to plotly map box, and this data creates the heat map. And here you could see that looking into our map, we can take a look, and then this shows the heat maps or heat maps availability. Here you can see that this area is related with Australia. So you can see that where the high density fire you could guess. And so that's why it's called the density map box. If you are interested in United States, and there the Hawaii, here you could see that the United States, this is the California where I live, and this is the southern part of, and that's all the volcanic ring. So that's another reason you could see there. And rest, this is the Alaska. We have seen some of this area. And one thing I just wanted to let you know that the data set which I'm using, it is possible that it may have the all fire signature. It means that it has volcanic fire, it has all kinds of fire. So that's the reason that so many volcano specific heat is also included in this data set. I didn't parse it because my objective was to have as many rows in our data set we can have, so we could get the performance related with modin. So this example conclude our comparison between modin and pandas. So if that's what you are looking for, I think that's enough for you. However, if you are interested on how you can have this large data set available for you and you could process and you can even build a bigger data set, I'm going to come at the second Jupyter notebook where I'm creating this data set and we are reading this CSV and we are creating this final data set. So you can also see the difference between modin and pandas. So let's get ourselves started here. So here I'm comparing the performance between pandas and modin when we are preparing the data. Means we are reading the CSVs, we are concatenating them together to so that we could create the final data set. So we are importing the pandas and modin pandas, and just for clarity, these are the different versions I'm using, and I always show these versions in my tutorials, so people or the folks who are watching this video, they have clear understanding of what versions, different libraries which I'm using in my tutorials. So now it comes to data set. So I already have a wildfire folder here, and if you look into a list of files I have, so there are lots of files available, and as you could see here, I have 6,436 files of wildfire data globally available. So now you will think where that data available, and this is the website. If you just click this website, this is a combination between NASA and the Department of Forest and several other agencies. So here is the website where you could get active fire map at any given time. So this is the place where you are seeing the active wildfire map. If you would want to get the data set, you can go to archive download, and archive download, here is the archive URL, and I was able to download all those files. So these files are what I have in my machine, and as you could see here, from year 2000 all the way to year 2022, I have data set for all wildfire worldwide. And what I have done, based on these files, I have selected these 6 countries and the list of files I have selected. So here you could see that I have 235 files, means these 21 year worth of wildfire data for these 6 countries. So I will be using this data set, I will be concatenating them all these into a one single data set, and that will be called the master fire data set. And this is just my previous example record. So here you could see that about 37 million records we are going to get, and if you look into here 37164 in our previous data set, 37164. So this data set which you have seen in my previous tutorial was actually taken from this exercise. So we are going to first use the PDO, means original pandas, and original pandas is referred as a PDO, and modin pandas is referred as PDM here. So first we are going to use the regular panda and see how much time it's going to take it. And here I'm using this TQDM. So you are going to get the progress while this whole code is running. So we are getting that out of this 235 files which we are reading. So we are reading individual file, we are getting that data frame out, and then we are concatenating these data frames. Here you could see that the original data frame is created as a FireDF, and everything is being appended here. After, because it's a list of all those data frames, we are creating the final data frame, and then all the data frames are concatenating here. So the master data frame is created. So this whole exercise going through for 235 times for each CSV file. So there is a time taken to read file from disk, that is regular IO, and then after reading the file, processing it, and then concatenating it. So you can think about overall processing, what is happening while this master data set is created using original pandas. So here we have read it took about 77 seconds for us using original panda. Now I'm setting up my modin here, so everything is ready. And if you see here that you already have a cluster running, it means when I was using modin, this Jupyter notebook was already running. So there is already a session available. So the best option is that if you would want to use more resources, you can actually take this and you can interrupt it. It means that I could take this kernel and I can shut it down. So let me save this thing here and I will go ahead and I will turn it off. So Modin get started, I will shut down this Jupyter notebook. So this Jupyter notebook is shut down. We don't need to restart. Now we come back here and we restart this. And that's better because now we have more resources available for ourselves. Now I'm using the Modin, and just to make sure we are using the PDM. So it's a pandas, Modin and everything, and we are reading the all file files. So let's get ourselves started. And one big reason you could use Modin is that if you are spending pandas too much and you are using pandas for very aggressive data processing work, saving 3 seconds, 5 seconds, 20 seconds, all these calls is going to add up into several minutes. And maybe by end of the day, you might have extra 30 minutes to hour available for you. And finally, it took 403 seconds while it was the total time 98 seconds. So it's all depend on where, when you are using and what's the workload in your machine. But as you could see here, we did not get any improvement while we were looping through with these 237 files. And it took almost 4 times more for us. So what I'm going to do, I'm going to take this code and I'm going to share this thing with the Modin team. And if they will suggest what's the best way to do it, something like that. But it did not work when I was using in my example tutorial. And the data frame is about, 37 million rows. And if you would want to save these files, whether you want to save as a ZZip or the regular CSV, you could use any of these. I'm going to share this code to Modin team, and if there will be any update, I will be putting another tutorial and I will show that how it can be done, and I will create the link from this tutorial to that tutorial. So that's all I really had in order to show you the performance between the Modin and pandas. If you are interested to learn little more technical details about Modin, please stay here. During my tutorial, I have already give you idea that speed Modin gives you because it takes the pandas workload and split it across all the available CPUs in your single machine. So distributed processing is happening at a CPU level. If you have Spark or other libraries where the distribution happen on a multiple machine, it is not like that. There are other libraries such as H2O open source platform which reads the distributed data frame, and they call them H2O data frame. If you are using the Spark, then Spark RDF, they are distributed data frame. They are split across multiple machines in a given cluster, and it supports most of these pandas objects. Depending on your need, you could set up your engine.putRay or Dask. If you will not set up anything, by default the Dask will be available and Dask will set up as the default, and that happens in my 2 of my machines. If you are interested in more examples and tutorials, you can always visit to examples related with Modin. So that's all I had for you in this tutorial. I do appreciate your time. If you like my content, please share it, subscribe it. It helps me, get going. So thank you so much for your time, and I will be seeing you in my next video. Until then, thank you so much. Thanks for your time. Please like it, share it, and subscribe it.